hope you get that applause at the end too. So I go into lots of these DevOps talks, and often they're focused on the application stack. And there's always an answer which is like, that's hard. And the question is generally, some guy at the back, it's like, stuck their hand up. What about the database? And everyone thinks, databases are hard. Yeah, we leave that to the data guy, and it's not really dealt with. Now, I built my business on doing DevOps for databases, and I think it's not that hard. I think there were lots of challenges, and hopefully over the next 45 minutes, we'll go through a lot of those, and you can walk out at the end knowing some approaches that you can take to really sort of make that happen, make your databases deploy from a CI/CD perspective. Quick show of hands, how many people are sort of operational DevOps and not data guys? Okay, and how many of you are data guys? Okay, so most of you are not in that data space. So I can slag off the DBAs and you'll all sort of smile probably. Pardon? Yeah, Rob, whatever. So yeah, I'm Simon Sabin. I'm a Microsoft Certified Master in SQL. I'm an MVP. I'm a Regional Director. So you cut me in half, it says Microsoft, but not everything has to be Microsoft. And I'm a founder of SQLBits. Who's been to SQLBits? Okay, why haven't the rest of you gone? I'm shocked. If you haven't known, we've announced the dates for next year. It's February 21st to 25th in London, so you should be able to get along, and we're going to do a lot of DevOps data stuff and dev stuff, so come along. So our focus today is going to go through why it's hard, what are the big challenges, some of the things that you can get your head around how to actually do things that then make it easier and means that you can actually get your CI and CD process out. Responsibilities are a key thing, so I'm shouting that out. We're going to spend a bit of time on that. Look at some of the common failures, and some of these are just common DevOps failures, but a lot are very specific to the data land because of some of the nuances. And then fundamentally, what can you do to get over those hurdles to get your DevOps process for your databases? How many people are actually doing continuous delivery with databases? How many are doing it for code? Okay. So probably 78% with code and 1% for databases, which is, how many people actually have SQL databases? Okay, almost all of you, right. So why is it hard? Anyone want to give me a reason why it's hard? DBAs. It's always the DBA's fault. Why is it hard for them to accept a DevOps process? Yeah. Data loss. Good one. Any more? Responsibility. What about responsibility? So they don't want to be woken up at 2 in the morning because you've deployed some shit code. That's a fair thing. Anything else? Opening up access. Oh, access to the systems. Yeah, that's a good one. Any more? Black box. So the fear factor, it's a black box, who knows what's going on in there, and that really goes on to the responsibility thing. And one of the big messages I'll talk about is the responsibility aspect is something that is an organizational problem that is probably the biggest impediment to actually getting this stuff in place. So hopefully we can go through some of those points. So yeah, fear is probably the biggest thing. Yeah, it's fear on a number of counts. DBAs have spent the past 20 years being considered the guardians of that database. And there's an element that they just don't have the skills. Yeah? They are stuck and They know T-SQL, they don't know PowerShell, they don't know C#, they don't know TeamCity, Octopus, whatever. They know T-SQL, and it's like, you can't really do bugger all with T-SQL. I mean, it's a bit useless, apart from move data about, but you can't do much operationally. So they fear that they don't know what to do. But there's also this, how many DBAs sort of, they like to tune that query, get that query down from like 10 minutes down to a second. They want to be that superhero. They want to be the guardians. They want to be looking after that data. But they secretly like that. Yeah, they like having that control. That control. Like they want to just control it. They don't want you to damage it. They want to control it. But the big problem is that control. If we talk about a proper DevOps process, and we're doing agile development, we need the responsibility to sit within the team. If you don't have that responsibility within the team, because the DBA is controlling it, he wants to review everything, he wants to deploy everything, then that process breaks. So you've got to get those responsibilities well defined. And then the tooling. How many people have tried to deploy databases through CI or CD? So given that probably 50% tried, and earlier 1% have succeeded, just goes to show the tooling is generally pretty backward. I mean, if you look in the dev land, I mean, we have providers here that do lots of great tooling. Developers can build tooling. So when they have a problem, they resort to writing some tooling to fix their problem. When a data guy has a problem, they only know T-SQL, and you can't really write a tool in T-SQL. And so the tooling ecosystem is really quite poor. And then that whole fosters the adoption piece. So tooling is this big challenge. And we will talk about some of that. But fundamentally, the problem with databases is data. So Guy talked about data loss. Yeah. The problem with a database is you need to keep this data. If you don't, your business is probably going to go out of business. And so how do we deploy a new version? How do you build a new bridge? Anybody from Scotland? So they needed to fix a bridge because the Forth Road Bridge had problems. So this old bridge has problems, so they built a new bridge. Side by side, great. Just redirect the traffic and job's done. The problem is, a database is more like a library. How do you build a new library and still let people have access to those books? Okay, you could build another library side by side, but then the books are in the old library. So how do you get the books from the old library to the new library? Well, do you just say, sorry guys, we've got to move the books. You're going to have this downtime. So what happens if you want to go and modify the books? You want to go and rebind them all. How do you do that? Do you just take all the books out and then rebind them and then give them back? The problem with that is that people don't have access to the books. So the problem is this data thing. And so with an application, you've got this ability to create a new one and switch it over. Xcopy, repoint, done. Very easy. Or you upgrade what you've got. And unfortunately for databases, you generally can only do that upgrade. You have to amend it. Now there's some bits of the database that you don't. So code you can generally just deploy. but you have to upgrade. You have to keep that data there. And so the database has to be upgraded. What are the options for doing that? Who the guys have tried, what sort of tools have you used for doing your upgrade? DAC packs? Anything else? Migrations, what, entity framework migrations type thing? Or Redgate or pun? Toolbar. So really, you have to go from A to B. Okay? You have to upgrade your database from where it was to where it wants to be. And so you have two real approaches to this. And really, they end up with the same goal. In the end, you end up with this upgrade script that takes you from A to B, that applies that upgrade. But your first option is you go and write that upgrade script. How many people manage a TFS instance or have done a TFS upgrade? So TFS, in their upgrade, they do this. Yeah? They have individual upgrade scripts that are written that upgrade the database from one state to another state. And what you find is when you do this upgrade, there will be hundreds of these scripts that all run sequentially to go upgrade the database. They found that is the best approach that they can do to achieve the goal. It's a reliable process, it does what it does on the tin, and they know they've got complete control. And they've got total control. The other option is the Gold Schema approach. So this is more DSC style. Who's using DSC? Okay, who's using ARM? Okay, it's all the same, yeah? I say, I want it to be like this. Some tooling will say, okay, what have you got? Figure out how to go from A to B. So Redgate, SQL prompt, SQL compare, is a sort of Gold Schema approach. SSDT, SQL Server Data Tools, is a Gold Schema approach. So these, you define what your schema should be like, and you then, at deploy time or prior to that, say, generate an upgrade script that will take you from A to B. Now, there's a hybrid approach which says, I need to do both. And I think one of the challenges that I've had with database upgrades is people go, okay, I'm going to do it all in SSDT, and so they think it's great, so they do this. And then they get stuck, because lots of stuff you can't do in this way. You want to go and migrate some data from one column to another. You want to apply a data fix script. What you have to do is you have to have a hybrid approach. And if you do post-deployment scripts within SQL Server Data Tools, that's what essentially the hybrid is. You have a Gold Schema which applies some changes, and then you have a upgrade script after that does some additional stuff that you have more control over. So you could just have a bunch of scripts. I was looking over very sad, I seem to have collected all the hard disks from all my computers over the past 20 years. Stack of hard disks in my office, and I decided I'm moving office, I'm going to get rid of these things. Thought I'd have a look on them, so go and find some projects from 20 years ago. And I had basically a database upgrade tool written in VB6. Yes, VB6, what VB6? And it just looked at a folder of files and applied those files to my database to upgrade from A to B. Worked like a treat. I had to have a lot of process to manage that set of scripts, so that when I do a release, I go to this set of scripts, and then when I go to version 2, I need to go this set of scripts, and then from 2 to 3, I do this set of scripts. But that's all process that you can manage. Gold Schema, so SQL Source Control Tools provide you the Gold Schema approach. SQL Server Data Tools, DB Maestro, there are loads of tools that do the Gold Schema approach. And then migrations, Entity Framework, ReadyRoll, provide you a migrations which help you write those tools, those scripts. But fundamentally, no tool can do everything. And I think this is a message I try and give to anybody we're talking DevOps is you have to be prepared to do something with to do that last 20%. There's always something that just doesn't quite fit how you run your database. And so being able to drop down to another language, PowerShell, C#, is essential. You have to be prepared for that. However, on the flip side, what I'd say is I've seen lots of places that go, oh, we need our database to look a specific way or do something specific, so we're going to write some tooling to do that. Now, the problem with that is that when new people come in, they have to figure out what that tooling does, how it does it. And so my big push is, if you're building new systems, build your systems to work with the tooling capabilities rather than go and blue sky your system and then go, ooh, my tooling can do 60% of it, and then I've got to write some custom tooling to do the other 40%. Do you really need your application, your database, to be structured that it needs that 40% of features that you have to go and write custom tooling for? Custom tooling is complex and difficult. You've got to version it, you've got to manage it, you've got to figure out how you test it and test deployments of it. It's all very difficult. Try and keep it simple. But DBAs, if you've got DBAs in your teams or in your companies, you need to get them to learn new languages. If all fails, turn to PowerShell. So it is possible, and I want to show you a little demo. And this is a demo I wrote a little while ago, and it was based on a situation where we were storing credit card numbers. Unsurprisingly, they were being stored unencrypted. That's what people do to start with. We realized we needed to encrypt these things. But the application didn't have the capability to go and do the encryption. So what we needed to do was figure out how we could encrypt this data that was coming and hitting the tables directly in the database and make it secure and encrypted. So, yeah, we had an insecure app storing credit cards. We need to encrypt the data. And the key thing about this, and this is one of the real big things, you need to look at the contracts. So one of the big challenges about database CI is about the fact that people don't think about the database in the same way they think about an application. If you've got an application with an API, and you go and change that API, what have you just done to all the people that use that API? You've broke them, well, unless you make it backwards compatible. Effectively, if you've got your application writing directly to your tables in your database, that's effectively an API. It is an API. They're hitting your tables. Now the problem is they've got access to all the tables, and so you've got a very leaky API. But it is still the same thing. So if you treat it like that, then you can then go and make changes, because SQL's got some interesting things like views that mean that you can abstract things behind, and so the API looks the same, actually under the hood, you're doing lots of magic. So this is one of the reasons why people like stored procedures, because under the hood you can make it do what you want. So that's what we do. So the target solution is data stored encrypted, and so we need to we have a credit card table which has got credit card numbers, and we want to change it to a view, so we're hitting that. So that behind it we've got an encrypted credit card table, and then the data is being managed by using some triggers, and we'll use the SQL Server cell encryption technology. So we need to encrypt existing data. There's a side-by-side time when we've got data encrypted and not encrypted, so we need to manage that. So backwards compatibility is not just about API, it's all about the data that comes back on the API. How many people have been using an API and then suddenly find that your app doesn't work because they've stopped sending your postcode back in the return response, or that they've changed the data that's coming back? Contracts are both the data in the contract and the interface itself. And querying needs to work. So we need to be able to query the table against the credit card number to see if the credit card number exists. So this is before insert selects to a table and after insert selects into a view, and the data goes to the trigger into the encrypted table, and the data comes back out through the view and gets decrypted. So the app doesn't see any difference. So what we have is I've got a little app that is running, that is inserting data into a SQL DB in Azure, and it inserts a credit card number, checks to see whether the credit card number is there first, and then inserts it if it doesn't exist. And I have a set of releases within VSTS, and I've got a set of branches at different stages, because one of the big things about doing good database deployment is to stage stuff. I see so many people go, doesn't work. We tried to deploy our database and we had a month's worth of changes and it just didn't work. And it's like, well, that's probably because you have to stage things in an ordered way so that the application will still work with your database. In this case, there's some features that we're doing that mean we can't just deploy it straight off, because if I just did all this, what would happen is when my query here tries to do a select from card where card number is X, from a SQL perspective, that card number is now encrypted. So the only way that SQL can find that card number is to decrypt all the cards. So it's scanning all the card table, and it's going to take a long time. So the point is, there's a bit of a backwards compatibility thing that what we need to do is we need to deploy something to the database, then we need to get the app to do a bit of a change to work with the new database, and then we need to deploy the next version of the database. So in this case, we are going to, if I show you, we have our cards with all nicely insecure card numbers, and we have our middle release which does a first stage. So if you look at our deployments, where's our deployments? So this is our general deployment phase. We are doing some BVT deployment testing to validate that the database deploys, and then we've got our production deployment phase, which is deploying it to our production database. And I've just preset this up so that all these have passed the BVT phase. This is my middle deployment and the final, so I'll just go and deploy these to production in the next stage. So I'm just going to approve this release. So approvals, very good from a DBA control perspective, so that they know when things are going to happen. They can see the database change that's going to be applied. They can see who's been pushing some dodgy code, because all the commits are tied to the build, so you've got good traceability. So we'll approve this. And this should go through, and we're doing this in a way that the apps are just not miss a beat. Now, how many people run an online system? Interesting. There's always a massive push to say, I'm going to do an online deployment. And it's like, that's really hard. Really, really, really hard. Trying to change the wings on a plane while it's flying, which is effectively what you're trying to do for an online deployment to a database, is very hard. If you don't need to do it, don't. If you can take 10 minutes of downtime just to have your app deploy, take it. Yeah? Hour, 2 hours. Crucially, make sure you have enough time to do your deployment and deal with doo-doo that falls out. If your deployment takes 4 hours and you have a 4-hour window, that's not good. Yeah? You want to have that room to be able to deal if something happens. So this should be going through, and it is now going off and scripting our database. So there's the script of changes. And what this will have done is once it's finished. So it's altering our card encrypted table, creating a new index, and creating a backfill script to go and move the data to set the encryption status to unencrypted. And that should be quick. And if we quickly have a look. So we now have, we still have our original table, which is actually now a view, with our encrypted data and our unencrypted data, but it's based off an a card encrypted table with our data still unencrypted, but we've got some additional fields here that allow us to control how we can do this data movement piece. What I talked about was the fact that when I go and encrypt the data, I don't want to scan all the data to unencrypt it. So what I'm going to do is, so what we should find is that the application is now going and I've got a v2 flag here. So I've pre-built my app. And what that does is it passes in a card mask and it looks up based on a card mask, which you're allowed to store unencrypted. And that allows me to filter some data down, only find that data, and then go and find whether the card is in my database or not. What I'm now going to do is kick off my final release. Now, I haven't clicked the v2 flag yet, just to show you the problem that would occur if we didn't have it. So that's kicking off. And what we should see is, at the point that this gets an agent, relying on VSTS's hosted agent, which is always a dodgy thing to do, for a demo anyway. Dum-da-dum. How many people be using VSTS? TeamCity? Octopus? Jenkins? Okay, all the above. Now, one of the nice things I've done here is I've got a table within my database which has got deployment information. And within this is a JSON string which gives me all the information about what database file was used, all the environment settings, who did it, what agent did it. So I've got total traceability within my database, so I can, if someone says, oh, the database isn't working, we can go and see, oh, there's a deployment here, and these are all the settings. Now, you can generally find those settings within the build, but this gives us a lot more granularity to go and access that and give your DBA a bit more sort of huggy-feely happiness feeling about your deployment. So you'll see the duration of our inserts has now gone to 2 seconds because it's taking so long to scan the table. And if I go and click V2, the second version of the app is passing in the card mask and basically solving the performance problem. If I'd have clearly deployed my V2 app first, I wouldn't have had that glitch. But it shows the fact that you have to think about these things in stages. You can't just go, I want to go from here to here, because that might not work. The classic problem is people go, oh, I want to go and delete some columns. We don't need them anymore. It's like, yes, but how do you delete those columns and your app still work? Well, I need to deploy my app first. Well, but if your new version of your app needs the new stuff, how does that work? So coordination is crucial. Putting things into small chunks, and this is where once you have a process in place, a process that does small chunks reliably, regularly means it's a lot easier to do these small chunks. You can do them within a sprint, within a couple of sprints. People go, oh, but I need to do it in the sprint. It's like, really? Can't you just do one this sprint, one next sprint? Is that a problem? So think about, engineer your system. I mean, if you're building something on the side of your house, you need to put some scaffolding up to get to the side of the house to build it. You've got to think about this stuff. You don't leave the scaffolding there forever. You might leave it there for a while to check, and then once you're happy with it, take the scaffolding down once everyone's not using the new feature. So think about the engineering aspect. And so if we go back to our encryption, what we now have is all our data being encrypted, card mask being populated, and the card number is now blank. So at this point, the database has basically taken ownership of that contract, that API, and the data within it to make sure that the interface out is the same.
Sorry, can I ask you a quick question?
Yes.
You used two different tables, though, didn't you? One's called card and one's called card encrypted. So what happens to the data that's in card?
Nope.
All you've done is add rows to the new table.
Nope. So card is actually a view. So you see there's no card here. It's just a view. Oh, that's not what I wanted to do. Didn't even want to do that either. The wrong buttons. Script, view, create a new. So what this does, for the sake of, we use decryption, so we detect whether it's encrypted or not. So this is how we do side by side. So this is sort of the engineering aspect. If it's encrypted, then we decrypt it with a key, and interesting secret management, but one has to do some stuff, and we can do key rotation on the cards and stuff. If it's not encrypted, we pass the card number, but it's passing on this card encrypted. One of the key things we did, we used one of the features within SSDT, which allows us to refactor. Refactoring allows us to rename an object. And renaming within SQL is a metadata operation, so it's like stupidly quick. It's like milliseconds. So we renamed the table, or SSDT will have renamed the table, and then created the view on top. And so the app didn't see any difference. And the benefit is you can insert and update a view, and it would work against the underlying table if it's a one-to-one relationship. That's how SQL works. We then take it to another level so that when you insert or update to the view, we use an instead of trigger, which is on the view. Triggers. Dum-da-dum. So we open up the key to encrypt the data, and then we insert into the encrypted table with the encrypted values. So we end up with this sort of we hide what is being done, and to the outside world, it just looks exactly the same. Any other questions? If you've got
that password, obviously, because that person is a DBA is able to see that, but that can also come from a keyword.
Yes. So all of these secrets are managed within the release management piece. There is currently an issue, the fact that you put any secrets in here, your DBA can see them. You can do the with encrypted thing to do a bit of obfuscation if you want. So it's a challenge you have to make. But at some point, so you could do these certificates based on Key Vault, and so you've got a permission piece going on there. So responsibility is not just about people. It's about the systems. Oh, sorry, no. Actually, so yeah, who is responsible for those changes? Is it the DBA or is it the dev? Do you have this cookie fight thing? Who's responsible? Both. Why is the DBA responsible?
Why is the DBA? If the DBA is supporting your dev team and helping create those changes.
So that's, I think that's the interesting, I think one of the biggest challenges I see in almost every organization we work with is there's not enough work in a sprint team for a DBA. So you have this shared DBA team that provides services. And that's really difficult to manage. And generally what we like to say is that you've got to understand that relationship, and the team needs to take the ownership. The DBA might help, but really the ownership needs to be within the team. And the reason I say that is because it drives a different mentality. The teams that we see it work really well with is where, because there's a pyramid, yeah? There's always like 50 times more devs than there are DBAs, and there's probably maybe similar ops people as DBAs, maybe less. But if you can get the devs to do stuff, that's how you can get stuff done quickly. And this comes back to the next point, which is, so that's about the team and having it all owned in the team, and I'm sure Sam talked about this in the making it work for teams. But the responsibility of the database is an interesting one. So, is your database a service? So we talk about microservices. Would you class your database as a microservice? Yes? No? It can do. So you can have it so your database is a service which, a single service boundary, your app and your database is one thing. Which means that when you deploy this app, it can go and make changes to the database. If there are different versions, the app knows, and so the app can go and manage where to go and get the data from. Or you have the database as a service, like we had in my application, where it managed what's going on. And so the data is moved in the background, and the app can understand the fact that there are two versions. Or actually, my example is the database is a pure service, and the app has no idea of the fact that there's versions or anything going on, and so you get one consistent behavior. Getting your devs understand this stuff. So getting your systems to think in this way and how you have that separation. Who manages the fact that this field is empty? And this isn't unique to databases. Cosmos, NoSQL, yeah, it's schemaless, but if you go and stop storing data in a certain way, your app's going to fail unless it understands that. And so that's generally what you've got in a NoSQL world, is this world where the app understands how the data is stored, and so the app controls that. And if the app is doing it, the devs are doing it, and they own it. So you need to define some rules. Without rules, it all breaks. We talked about backwards compatibility. That means no dropping columns, no changing data types, no renaming stuff without putting something in place that points to the old one. Just like doing app development, breaking changes as the last resort. So the other areas that we see is databases are complex, and people try and do the whole thing. Big waterfall, let's go and do the whole thing. You can't. It's really complicated, really hard. It's like automating is hard. Making it reliable, and reliability is the big thing for me. You've got it, is so hard. So look at your process. Do you need to auto-provision your stuff? If that only happens once a month, yeah, I know it means you can provision lots of new environments very easily, but do you really need to focus on that at this point? Or is it better to be able to deploy stuff, your dev deploy their changes on a daily basis? Look at the value stream map of your process and focus on that. Reliability. Formula 1 fans? Yes? not doing very well, are they? Because they've got poop reliability. Focus on reliability. Data guys love reporting, love data. You can do all sorts of metrics to figure out how it's reliable. Is it slow? And keep it simple so that it keeps it reliable. And keep measuring failure. And then the other aspect, people trying to do it all in SQL. There are other languages. They've got to learn PowerShell. Choose the languages. Just having people go off and choose Ruby and Python and whatever, it's like, that's great. But if you're a company growing, you've got to decide what your skill set is that you want to recruit for and you want to support. That's something I've figured out, especially in a database world where the breadth of accessibility of skill set of programmers that have got broad skill set is very small. And so keeping it to a consistent set of languages makes it a lot easier. So, keep it simple. Simple is important, especially from database. If you try and do things complicated, it's going to be really bad. Simple means trying to do small changes. Trying to do small changes incrementally is a lot easier than trying to do really big changes. There's lots of interesting little things you can do to make database DevOps working. So batching updates, preventing locks, those types of things. And if you're interested in those things, you can come and see us afterwards. Auditability. So people talked about fear. The DBA wants to own stuff. The compliance story. My view is DevOps and compliance are just like in bed together. It's a fantastic story. You've got full auditability. I've had so many clients that someone's gone, oh, I don't want to, they've deployed the wrong script, or they've deployed something at the wrong time, or they've thought they'd go, oh, I don't like that, I'm going to make a change to it on production. It's like, yeah. Having a pipeline, I mean, you know, guys all know all this, having a pipeline gives you this auditable, traceable process, which is fantastic from compliance. GDPR, anyone? Anyone doing GDPR? I mean, it's a wonder really for that. Set some simple rules. People don't like to set rules to say, oh, you can't do this. Bugger that. For me, any frameworks in the cloud world today, there are defined rules. That's what makes it work. If you step outside of those rules, it doesn't work. Cosmos is awesome if you do everything within the boundary of rules that make that work. SQL is awesome if you do everything in the boundary that makes that work. If you step out of that, if you start doing like big updates to documents within Cosmos, it doesn't work great. If you want to do multi-aggregated queries against multiple documents in Cosmos, it doesn't work. Yeah? You have to set the rules, fit those rules. So backwards compatibility, don't change data types, those things, really important. Don't try to do too much. Do it in small chunks. Focus on reliability and get a proper language. If it feels awkward, just a little takeaway, it probably is a bit wrong. Go and ask someone. WinOps, there's a SQL Slack community channel, there's Stack Overflow, all those things. Go and ask people. Most things have been hit before. We sit on the Slack community channel, we sit in Stack Overflow, we can give you answers very quickly, very easily. If it feels wrong, it probably is. So go and ask. And to that, any questions? Wow, stunned you.
Do you define a transition period between the states? So you are like you have implemented the database, you keep it comfortable with the past. So do you define the transition period so that the application database keep it synchronized?
So are you saying, are you asking, do we define the period by which we are going to get rid of, support the old versions? Yeah, I mean, just like any application. If you go to version 2, you've got to say how long you're going to keep version 1 for. And I think one of the challenges with databases is because you essentially have this leaky interface of APIs, trying to figure out all the applications that talk to you is very difficult. And so invariably this is where you end up supporting lots of things. And so some good recommendations, making sure you've got app names within your connection strings so you know which application is talking to you, so that when you find out this application is still talking to this table, you can go and say, go away. Other things you can do is one of the things I don't like about databases is generally, apart from security, people have access to everything within that table, in that database. You can create a separate database which has got little views that point to your other database. So you've now got a very nice abstraction layer, and you know they're only accessing those tables. So there's lots of little things that you can do from an engineering practice, defining interfaces. So if you've got databases talking to databases, you can do a little DAT pack for those two views that people access, and people only reference that DAT pack, rather than you producing a DAT pack for your whole database and people have access to that. Because then you know, if they build against and reference your little DAT pack, they're not leaking and sneaking and querying other stuff that they shouldn't be accessing. Just the same as public and private interfaces for applications. So that's the thing. Think about how you do this from a development, from a C# perspective, and apply some of the same rules into your database. Cool. Well, some cards here if you want, and some USB sticks. They're a bit un-PC in the fact that they're very old Windows Azure USBs. I'm sure I should probably throw them out, but if you want them, 2 gig USBs up here. If you've got any questions, feel free to email me, and we're happy to help. Thank you very much.